Okay, for this video, I want to talk about Booleans, right? And so Booleans are, as I covered in class, a way of taking two pieces of geometry or two different objects and then either welding or subtracting from each other to create a new, more complex object, right? So all of these objects were created using Booleans, right? So this one right here, we have two cylinders that have been welded together, right? For this one right here, we have a cylinder that has another cylinder being cut out of it, and also just for fun, a sphere being welded on top of it. Right. This one right here is a cylinder with a sphere welded onto the side, right? And you can see it's significantly different, or the topology and the surface deformation can be significantly different when the surface is curved, right? When you're making that welding or cutting that hole in a curved surface. So it takes a lot more consideration when you're welding something onto, or cutting a hole onto something that is a curved surface than on a flat surface. On a flat surface, it tends to be pretty darn easy, and you can kind of do whatever, not whatever you want with the topology, but almost anything you want to do with the topology. All right, this one, what it was is a cube with a sphere, right? So I just had a cube and a sphere. And I just did a intersection, right? So I'll show you how to do this in a second. Booleans, intersection, and that's how I got something that looks kind of like this, right? And then what I did is I welded another circle back onto the face, right? So that's how I got this kind of shape right here. And those holes, those aren't Boolean at all. Those are just me extruding and inserting. Okay, this is a object where, okay, and this is a more custom shape. So I just took a cylinder and shaped into the shape of a vase, and then I used a kind of customly shaped object to cut a hole into it, and then cleaned up the geometry and then connected the vertices. Okay. This down here is a cube that has had a sphere cut into it, right? And so let's go ahead and start talking about how we might do this and what we need to think about. For Booleans, it's a pretty simple operation to do it, right? The actual function of how you take two objects and you combine them together using Booleans, like how Maya does it, it's pretty simple. Maya's going to handle it pretty darn well, right? I'm going to go ahead and rotate this upside down. Let's cut this cone into this sphere like this, right? And so it's deceiving because it can be really easy to create a mesh like this, but it's going to inherently have a lot of problems with it. So in order to do Booleans, you have two objects, and then you choose your primary object first, and then the secondary object second, right? And then you go to Mesh, Booleans, and then you have three operations: union, difference, and intersection. Union, it doesn't really matter what order you select the objects in, it's just going to combine them together, right? And you can see here the inside of this cube, whatever was inside or was being overlapped, the part of this sphere that was being overlapped and the part of the cone that was being overlapped is deleted, and then the edges and vertices are combined together, right? It does a terrible job. If I turn on smoothing, you can see how bad the topology is, right? I got a bunch of n-gons up here. It doesn't look like that visually. I mean, you can see the n-gons, but you might not notice it. But anyways, I just wanted to kind of show that. All right, and so now let's go ahead and take a look at the other ones. Let's go Booleans, difference. So the way difference works is it cares about which one you select first, because that's the one that's going to stay behind, right? So if I select the sphere, then select the cone, and then go Mesh, Booleans, difference, right? You'll see it cuts the cone out of my sphere, right? And if I do it the other way, cone first, then sphere, Mesh, Booleans, difference, cuts the sphere out of the cone, okay? And then last is intersection. Intersection also doesn't really care what order you do it in, because it's just going to give the pieces of the geometry that are inside of both of those objects, right? And combine those together, okay? So what's really important about this is to get Booleans to work properly and have good topology, you need to there's a couple things you can do, and a couple things you're going to have to do. The best thing to do is to prepare for the number of polygons you're going to have, right? So making sure that the places where they're going to intersect have edges that line up with each other. Let's take a look at this cylinder and this tube. So what I do is I'm going to create a cylinder. I'll just kind of recreate this over here. Let's scale it up. And I'm just going to go ahead and create a tube. So I'll write, oop, not that one. What? Not that, sorry. Where is the tube? Is it this one? Pipe. Okay, it's called pipe. Okay, I'm gonna move this guy over into position, rotate it. I'm not gonna modify any of the topology yet because or delete any of the edges or vertices or anything like that because I want to be able to manually change those these edge counts, right? So what I'm gonna do is I'm gonna turn on wireframe unshaded. And I'm going to try to get this so that these edges are going to line up with each other, right? Right now this is going to do a pretty good job because both of these by default have 20, so those edges are going to naturally kind of line up with each other. So this is a pretty easy object for the most part. So I could probably weld this right away if I wanted to. I'll make this a little bit smaller than the other pipe, just a little bit, right? And then, so what's really important is noticing how those edges are going to connect and think about how you're going to start welding them, right? This is, like I said, a fairly easy object to do. So what I need to do though is I need to make sure I have edges going this way as well, right? We can take a look at this one. We have this edge going up that way, but we also have this edge going across that way. So this has more topology, so let's go ahead and at least add, let's add it to this one. Add it to this guy. All right. We can probably get rid of some of these guys once we're done with it, just to kind of reduce the number of poles. I'm just going to put them there just in preparation. A lot of this is easier to do while you have your object, before you actually weld these objects, right? And I probably don't even need all these edges, because as you notice on this one, let's see how many, this is 8, right? Is that I didn't really need to do that for this one. I just had one going across that way just to kind of keep the topology okay in that area. So I probably don't even need all these edges going that way. So let's go ahead and get rid of these. I'll do Shift Delete, or Control Delete, sorry, to get rid of those vertices and the edges. And so now what I'm going to do is I'm going to weld these guys together. So we'll go Mesh, Mesh Booleans, Union. I keep calling it Weld, but it's called Union. And so now what I need to do is I need to start merging vertices, right? So what I'm going to do is I'm going to grab these vertices here, I'm going to merge into the center. If I like the curvature or the shape of a particular object, whether that's this guy or the main pipe, right, then I might, instead of just merging to the center, I might use target welds to merge the vertices to the vertex that I want to stay still, right? So I like, let's say I like where this vertex is, so I'm just going to merge all my other vertices in this area to that location, right? So just getting rid of all those extra edges. And almost all of these guys are going to need some work in that regard. So I'll go here. Okay. Take these guys, I'll just merge these guys in the center. And I'll press G to merge into the center again. Okay. Let's see if this one has that problem. See, that side's not great. And let's go ahead and I'll go ahead and insert, well, it probably won't let me insert it actually. So let me just keep cleaning it up. So we'll go through here. So these two I want to merge together, right? You can see there's, looks like I only selected one, but there's obviously two there. That one's good. Select these ones, merge, these ones, merge, these two, merge. Oh, and I think I grabbed and merged the wrong thing. So merge. Oop. Merge. 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 Okay, and so just take some cleaning up. Instead of doing this by hand all the way around, I'd probably just end up mirroring it. Merge. 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 And merge. Okay, so I merged those. I'm not seeing any ingons. It doesn't look great, and that's just because we don't have any really holding edges to kind of support that. So what I'm going to do is I'm going to put an edge loop down here closer. And let's put another one up here. Just need a few more edge loops throughout my object just to kind of help keep the shape. Because when we smooth it, each edge is going to be pulled between every single, it's two boundary edges, or the edges that are on the other sides of it. So if I smooth that out, let's go ahead and assign an existing material, blend 3, so we can take a look at that juncture. And I'm going to go back in here, see if I get rid of these supporting edges. Not this one, not this one, and let's do this one too. Okay. And then what I might do is I might go ahead and, since I have an end gun going this way, I'll go ahead and merge this guy back here. Let's try that and see if that works. And let's turn this off. Let's just double check I have quads, yep, and maybe I'll add another edge loop somewhere over here. Okay, and so now I have this fairly nice weld. I didn't worry about the other side because I have that end gun. I didn't clean up that area, but I can just easily cut my mesh in half and mirror it, right? And then I'll go ahead and I'll add some bevels to my object. So grab these guys. And this isn't part of the Boolean cleanup process, it's just me, being more nitpicky about this. Right? Okay. So we got the cylindrical weld using more loops than this one did, right? So I probably used more than I needed to because this one looks just as nice, if not nicer, but just kind of showing that process. Okay. You can see here with this, actually let's take a look at this one. This kiln object was made by taking, let me go ahead and move these guys over. Oops, wrong one. Let's move these guys over. It was actually made by just intersecting a custom hole object, and this was made based on a student's object. So I'm going to go to my downloads, and we have this object right here. Okay? And I'll have to worry about the actual shape of this. There's a different kind of approach and a different video of creating this tube mouth. But what I'm going to do is, there's a couple ways I could do this. One is I could prepare the hole, so I can go over here. I could not using Booleans, right? So I could actually grab those faces. I think it's probably like from here, maybe these guys, right? And then extruding and then offsetting. Let's turn on flat shade so we can see that a little bit better. Offsetting it, and then scooting these around to get the shapes right. This is a totally valid approach. It's the nice thing about this is the good thing about this is it's going to be easy to keep the topology clean, right? I'm not going to run into weird Boolean issues where I have floating vertices and edges that are really complicated. So I'll come over here and I might start sliding along my surface. So let's do surface slide, and I'll just grab these guys. Let's pull them up a little bit, pull this one up a little bit, right? The difficulty we're going to run into here is that the curvature of the main body is we're probably going to lose it at some point. So let's go to blend 3, right? We're going to lose some of the shape of this body. You can see this is kind of pushed out a little bit more and this is pulled in a little bit more, just because as we're sliding along and trying to custom make this hole on the shape, we don't have anything to reference on, right? Instead of doing it the way I did it, where I was extruding and then scaling it down this hole, what I could have done is I could have also maybe used like the multi-cut tool and then cut into it, right? So the nice thing about this one is that, and I'll just worry about one side for now. The nice thing about this is that I could easily, get the exact shape I want, and as long as I understand the topology I'm making, and I've already messed it up because I have an n-gun right here, then I can kind of cut in the exact shape, and since I was cutting on the surface, I'm going to get the curvature and keep the curvature of the surface that I was cutting in almost perfectly, right? And I'll have to keep in mind topology concerns, and what's gonna happen to the mesh when I smooth it, right? Because poles and unevenly spaced polygons are all going to be issues with smoothing of the surface, right? They're going to cause visual rendering artifacts, right? But something like this, and I can go ahead and click mirror, and I want this to go in the x-axis and the objects. There we go. Ignore those holes in the background. Okay, and then what I want to do is I need to fix this problem with this n-gon right here, because I have a 5-sided polygon right here and here. Turn on symmetry object X. Easy thing probably would be just to try and see what would happen if I just weld those points together. Okay, assign existing material blend 3 just so I can take a look at it, and it's okay. I probably want to go ahead and then grab, I need to do this on the bottom too, another n-gon. Right. And then what I'd probably want to do is I'd want to grab these edges and then like maybe extrude in and scale in. Let's turn off surface slide, or edge slide. And then I'm going to turn off symmetry. Okay. And then I can extrude this in. Alright, and I have some pinching here, so you see that how that surface is kind of deforming a little bit around the lip, but it's pretty good. So the other way I could do something like this, and this is how I got this one over here, is the same thing we did with this pipe that we made over here, but we're going to be cutting out instead of welding together. Let's go ahead and assign our blend 3 to this. Right? Keep this flat shaded just so it's easier to see. I'm going to turn on the wireframe on shaded, and again, what I'm going to do is I made this cylinder a certain number of edges so that I can kind of see how it's going to line up with the topology of my main body. Let me go ahead and I'm going to duplicate this, hide it, and then I'm just going to really quickly go mesh smooth just so we can see an instance of where that might cause a problem. Okay, so don't worry too much about these guys. Okay. Okay, I'll just delete these guys. The main thing I'm trying to get is I'm just trying to get more edges just to show you guys an example of what would look like with an uneven number of edges between the two objects. So I'll take this mesh, and go to mesh Booleans difference. And it's a beautiful hole, right? It's, great cut. The problem is, when I smooth it, I'm going to get all these rendering artifacts from all these n-gons around the boundaries, right? So now I need to start cleaning it up like I did with the other one, where I need to merge these vertices. The issue I'm running into is I now have way more vertices around this hole than I have vertices nearby, right? So I'd have to start doing things like add more edge loops to my object so I can stitch them together, right? And I don't want to do this because, as you'll see, if I didn't plan for this in the original design of my object, it's going to cause a lot of, it's just going to kind of mess up the shape I originally created. By having to change the number of edge loops, I'm messing with the curvature of this object. And because these number of edge loops and the spacing of these edge loops are not the same, I'm starting to get some pinching and pulling on my object, which is a huge problem, right? So that's why, let's control back to before this. Okay, I'm going to delete this one. That's why I made sure that this little cut object is fairly low poly and a similar number of polygons with this one. So take this guy, mesh Booleans difference. Okay, and just like with the what I did over here and what I did with that cylinder is I'm just starting to combine and weld these points together to make sure we have object X on, right? And it's not doing it maybe because it's not perfectly symmetrical, which I'll just have to mirror it across. So I'll just go there, weld, and I'm just kind of being swift about this. Okay. These guys, weld them, and I'll weld it to that one. Right. And this one I'll just leave this gap here so I have this quad running across the top, because if I weld these together, then what I'm going to get is a triangle right there, which I don't really want. Right. And I kind of have pretty much the same thing I'm going to have over there. And so what I'm going to do is I'm going to insert an edge loop, right? Add another edge loop right here, add an edge loop right here, and smooth that out. And you can see, you know, we have kind of the same effect going on. And so there's two different approaches you can take to a lot of these objects, and that's just what's probably easier about this one right here is that I can get that really custom shape out of that other object, you know, especially if it's like a really smooth curved object that's kind of complicated or it would be too hard to cut out a specific shape, right? So we looked at how we could just cut onto the shape and create a hole, or we can use a Boolean to cut in the shape, or we could just use like extrusion to push in and then pull vertices around to get the shape. This isn't the example. I deleted that example, but depending on how well you plan out your topology and how much you clean it up, Booleans can be great at getting these very particular and hard to capture shapes, or hard to model shapes that would normally be very difficult to do by hand, right? Okay. A couple other things I wanted to make a note about. Here, cutting and welding with spheres is generally okay, but you have to keep in mind what's going on with topology of a sphere, right? A sphere compared to, say, a rounded cube, right? I'm just going to create a cube, move that over, and let me go ahead and smooth this guy out. So we'll go mesh, smooth. Let's say 2, right? I don't want to get too dense, or I'm going to have, you know, you don't want your, if you can help it, keeping your meshes low poly is great. So we have very different edge flows on these guys, right? Let me turn on wireframe unshaded, right? We have like a cube, which is a top, front, left, side, back, bottom planes that are welded together at the corners, right? This one right here, we have something similar to a cylinder where we just have stacks of radial edge loops, right? And so this grid of radial edge loops is actually kind of nice, but the issue we always run into with spherical and cylindrical topology is what to do with the pole at the top and the bottom, right? Which ends up being a pole of X number of sides and a bunch of triangles that are annoying to have to deal with, right? As opposed to what's advantageous about a cube topology is the poles are at these little corners, right? And they're fairly predictable, right? These are all quads. These are still all quads, whereas this comes down to triangles, right? And then the top and the bottom of this and the front and sides are all the same, right? I'm not having like difficult little areas on one part of the mesh, right? So there's some places where you'd want to use a cube and some places where you'd want to use a sphere. I'd say if you need part of the mesh, that is, let's turn off this. If you need part of the mesh from like here to here, right, in between these areas where you're just having these radial up and down, left and right edge loops, cylinders and spheres work awesome, right? If you're going to be worrying about like all the way around, or you're going to be having a cut on, or you have to worry about like a corner and you just need these edge loops to still line up with your object, then using something like this, like a cube or another option, would be a good choice. So you can see here I have the same cube that I cut with both a rounded cube. So I took a rounded cube, put it in here, and then started subdividing and welding these points together. And then this one over here, I used a normal sphere and cut into it. And so the normal sphere, like I can come in here and I can start figuring out how I'm going to work on this, right? I can press enter. Let's go over on this one, press enter. Go on this one, press enter. You know, there's definitely ways I can clean this up. And I probably don't need quite this many edges. Let's just delete about half of them just so I can have something that's easier to kind of clean up for this example. So I'll cut this one, oh, not that one, I want to move it there. Okay, whatever, enter. And then I'd keep cleaning that up. And then same thing with these ones. And obviously, as you are starting to note, you know, it would have been easier before I did this Boolean to actually cut those pieces out of the actual or make sure I did this beforehand on the actual cube instead of doing this at this stage, right? Because it's easier to add those edge loops on the cube earlier, right? And then I'd come in here and I'm going to start, you know, just combining these all together, and this is all looking okay. This part down here, I still need to figure out what's going on or what's going to happen here, right? I might delete like every other edge or something. Like, let's just delete all these ones and just figure out how they're going to go across, right? So I'm going to go ahead and do this one across that like this, right? Press enter, and then maybe this one goes across like this, right? And then this goes down there like that. And I'm, you know, I'm starting to. One second. Let me go ahead and pause this, and I will. Okay, and so as you can see, this is compared to this one. These edge loops are very kind of unevenly spaced, right? It's taking a lot more cleanup than this one did. And so, you know, I can get to the point where I can clean this up and fix it. You know, I'm starting to get there, but I still need to do a lot of work. But, you know, going ahead with a rounded cube instead of going with a sphere would have probably been easier approach in this case, right? And you won't know exactly which objects to do and how to do this in all situations. So sometimes looking up some topology references online will help you kind of figure out how to use or how you might want to lay out your topology if you're trying to aim for something different. So my recommendation is for all of any type of object where you're going to weld them together or you're going to cut out between them, is to plan your topology and try to get the edge loops to line up as best as you can. They don't need to be perfect, right? And you can sometimes do some funky topology, as you can see in this one. This is not as cool looking as the other one or as clean looking as the other one, but it still works, right? So it doesn't need to always be perfect, but it needs to be something that you can make sense of, because Booleans, especially cleaning it up, can take a lot of visual focus or a lot of effort in terms of like understanding the topology, where everything's going, and how to make whatever you have better. Okay, and so that's kind of the basics of Booleans. I think for the most part, they're pretty straightforward. Let me go ahead and do like 2 or 3 more objects just to show you guys different approaches, right? So in order to do something like this one right here with the sphere is actually pretty easy, because what I had was this cylindrical object. And then what I did was I took a sphere and I essentially welded it to the object. I mean, this is probably one of the easiest ones to do. And what I did was I just, you know, brought this to a lower subdivision level, right? Let's take this down to 12. Make sure this one's also the same number, right? So the edge loops are going to line up with each other, right? You can see that, it's pretty easy. And then I just did a mesh Boolean union, right? And it's going to be a pretty darn clean union, right? We might still have edge loops that are separated or not connected, but in this case, since these are lined up almost perfectly, it seemed to do a good job. I can go ahead and let's do a difference instead. If instead I wanted to cut a bowl into that shape, right? And I could do it other ways as well. Another way of looking at this is Booleans are kind of like the slightly shorter method of adding or subtracting objects from each other, right? I could just as easily plan this out in the same way, and then, you know, take this object right here, oops, and, you know, delete those. Let's go ahead and, yeah. So I'm gonna, from here, I'm selecting an edge loop that's on the inside right there. Let's go ahead and shift right click. I'm gonna detach my components, or I can find that under edit mesh, detach components. Or is it under mesh? I don't know where it is on the actual menus, of course. I'm sure it's here. Oh, detach. There we go. Detach. What that does is it makes these, makes this cylinder is now made of 2 different objects. So I'll select this, go to face mode, double click down here. Oh, let me just make sure I'm detaching this. Detach components. There we go. And then what I can do is I can, you know, pull this up. Let's turn off the wireframe unshaded, or X-ray. And then I can come in here and I can make sure I'm going to insert an edge loop pretty close to here, and then I'm going to scale this edge loop in until it's right there, right? Or I might just actually, I might just delete the cap. So let's do what we were doing right there. This will make it easier. So I'll just grab this edge right here, scale it in to right around here. And now I need to prepare this object as well. Face. So I'll select all these faces, not this face, and not these faces. So I just want that cap, delete that, open up that cap. Okay, show my objects. And then I can just, grab these two, mesh, combine, right? And then I can, maybe I'll just go ahead and I'll delete this face here. Oops. This face loop here, poly loop, and then grab these guys, and then bridge, right? And same process, right, as the Boolean, right? The advantage of this would be, the earlier demonstration of this, it was almost, it perfectly did it, but most of the time, about 90% of the time, 95% of the time, Booleans are going to not weld the points correctly, right? And so the nice thing about this is I won't have to really do any cleanup because I kind of know the process of how I'm making this, and I'm doing it by hand, right? Whereas Boolean's going to do it automatically for you, but it's going to most of the time, make some terrible geometry for you, right? Okay, let's take a look at a few of these other objects. All right. A hole is very simple. It's very much like the kiln, right? Whether we create a circle and extrude into it, or we use a cylinder and cut into it, or we cut a circle on the object and then extrude, it's kind of the same process for the most part. Let's take a look at something like this one. So what I'm going to do is I'm going to create a cylinder. So let's pull this up. I'm going to rotate this, so C in this direction. And I actually did this with the hairdryer example video I created earlier. It's going to work with a lower poly count just to make this simpler for me. So let's go to, I don't know, like 12. And I'm just going to use the same one. And then I'm going to rotate this one, J, right? And push this over here. And it's the same idea or concept, is that I need my edge loops between these two objects or edges where they're going to meet to kind of connect, right? Let's go ahead and make this, oops, always press the wrong button. Make this a little bit bigger. And so you can see, because these are made from the same object, it's pretty easy to do that. Let's go ahead and, let's do two versions of this. I'll do this one, right? I'll pull this one up, and let's instead cut this from this side. So I'll move this up, move that there, and maybe we'll do it like that. And let's do it like this, okay? So this is going to work fairly well, I think. The thing I'll probably run into, or the issue, is that because these are going in two different opposite directions in terms of the spacing of the polygons, you can see if I look at it from this way, these are really tight. This gets a little bit wider. This is the widest, a little bit shorter, and then it gets tight again, right? And so what happens is it's going to be hard for me to line up these edge loops that direction because of that issue, right? But I might just go ahead with it because I want to keep it fairly low poly. Okay, so I'm going to take this mesh, take this one, mesh Boolean difference, and we cut out of it. And actually, it might be pretty easy to work with. I'm not sure. Let's take a look at this. I'll weld this. Go ahead and work on welding these ones. So I'm just doing merge to center, which is under edit mesh. And then once I've done it once, I can just keep pressing G to repeat the last tool that I did. Okay, and I'm noticing those guys welded fine, those guys welded fine, these guys did not. Oops. Okay, these guys did not. And then, I have this terrible geometry from the cap of my cylinder, which I probably should have cleaned up before I started, but it's not the end of the world. And then what I might do is, let's go ahead and weld these two edges together. You can see I have this, it's right here. There's these two edges that are very close to each other, and so I'm just going to go ahead and weld them together. Okay, and so what I might do is instead I might have to cut this in half. Okay, that's right. So that I can do on both sides. So I'll take this, and then I'll target weld it here, and then the other one should have collapsed. Okay. And it looks like it's hard to tell. I don't know if I have a polygon. Yeah, I have an end gon. So I have an end gon going this way. So what I'll need to do is I'll need to cut so that I cut this into tries. So first I'm going to use this tool to the multi-cut tool with holding control to drop in an edge loop. Connect this way. And I'll do the same on the other side. So connect that way. All right, I have a triangle, which I'm not in love with, but it'll work fine. I have an end gon right here. So what I might do in this case is I might just go ahead and collapse these guys. So let's go and collapse them. And so I don't want to pull this up from the bottom, right? Because then I'm going to get this crooked edge, and you'll just see that here, right? Merge it. So now this bottom of it's crooked. So instead, I'm just going to merge this guy down to using target weld. And I'll do the same thing on this side. And then what I might do is I might actually just, to make this a simpler bottom, I might just grab these guys. I'll move it up a little bit, so now this is quadded out, and then I can just scale this down. And I'm not going to worry about these guys down here for the time being, the bottom of that object. And so let's go ahead, and I'm just going to do a little beveling just to sharpen some of these boundaries. Okay, and I'm just going to add a bevel. So let's do that, and let's add a few holding edge loops in some areas. Oh, so we still got an end gon right there, so that's definitely a problem that needs to be fixed. But before I do that, let me go ahead and just still add these, and then multi-cut. Multi-cut. Okay. And I'm getting really messy with this. For some reason, those did not create an edge. I might mirror it at some point, just to kind of keep it consistent. But you can see here we did a fairly decent job of cutting one mesh from another mesh to get this really, modeling this by hand probably would have been a pain in the butt, you know. But you know, with the Boolean, if we get the poly count the same between the objects, so or fairly similar, and then we also get the what I'd do here is I'd probably just do that, which creates a pole right here, which always interferes with the shading. And if I go to assign existing material, blend 3, right, and you can see it's pulling it right there, so that taper we're getting around the edge, that's fairly consistent, kind of stretches right there, right, which with our current poly count is unavoidable. But let me go ahead and just drop this down like this. Okay. You know, and so that's just, you know, there's, with the poly count we have and keeping it fairly low, there's only so much we're going to be able to do with this, okay? And so the other type of cut, you know, because these edges, like these two objects are more or less oriented the same, like these, it's kind of hard to explain, but these, you can see if I look at it this way, as I was looking at the other object when it was, let's say, I'm going to duplicate this, move it over here, duplicate this, rotate J, move this up, right? Right, when I was doing it this way, where they're kind of going perpendicular to each other, the two cylinders, let's scale this down a little bit. You could notice that when I looked at it from one direction, or from one perspective, the edges weren't quite lining up, right? So a good example is, you know, the spacing for the polygons here are pretty consistent with each other, but lining up this one, this face right here relative to this face right here is really, really squashed vertically, right? This one's a little bit more even, and this one's like the same, right? right? And so because these are kind of turning in two different directions, these polygons, when they weld together, their edges aren't going to really line up that as well. And so that's the main difficulty between those objects. Whereas doing this one is going to be fairly easy because those curvatures, it's kind of hard to explain. I don't know how to kind of articulate it, because it looks like they should still also be kind of opposite each other. I still got the end gone on that one. So what I can do here is, what I'm going to do is I'm going to subtract this one from this one. So I'll take this one, and then we'll go mesh booleans difference, right? And this one's going to be pretty easy because those polygons pretty much lined up perfectly with it, right? And so what I might do is I'm probably going to grab these guys, and this is going to come to a point which I don't really like as much. It's going to look kind of not as nice right there, right? You can see how it's distorting across that, or trying to bend the shape down isn't super great. And so what I might do is I might go ahead and let's see if I can cut this really quickly. I might weld these guys together so I don't have this really long stretched polygon right there. And so what we can do is we can just weld that to the center, and there we have. Now I have these quads there, which are nice. And I can do the same thing down here, where I'll just grab these guys, weld them, and then grab these one, and then weld them, right? And then I can do the same thing I did in the other one, where I just go around, oops, and use bevel. And the nice thing about this is, or the nice thing about doing this with beveling is beveling likes to, or will create kind of like a holding edge for us around the object, right? So now we have this kind of crisper shape. Okay. All right. And then the last one was just this sphere, combining these spheres and cubes. And I kind of talked about that down here, but in this case, to get this like easier polygons to work with right here, I used a what's it called? Rounded cube, right? So I can get those kind of corners right on the edge. You can see the rounded cube corner right here. This here is that corner of a rounded cube right there, right? And so it gave me that topology that worked really well right here. Whereas down here, you know, with the normal sphere topology, it did not work that nicely. Get this flat surface. It's fairly straightforward. You know, I could do something like, let's add a really complicated object with a, and so what I can do is, say I have this, pretend I have like a more complicated rounded object, and I want to flatten it. Actually, let's just go ahead and use an example I have. Let's take a look at this radial one, and I want to look at this one and not this one. Let's take a look at these guys, and let's hide this Boolean kit. Let's just take a look at, where's that example? I don't know where it went. Oh, okay, I have them right here. Let's just pull this one over to the side. All right, so if I had this flat object right here and I wanted to create like a flattened surface, it'd be as easy as me just, you know, taking a flat object like a plane and then moving that into position, and then I probably wouldn't use a plane. I'd actually probably use a cube, right? And the same thing is, so I want to try to snap this to the surface. So I'm going to hold V to snap it, just to line it up. And let's say I want to cut a hole like that. And then I'd probably try to make sure I had a number of vertices that are going to cut nicely into this, right? So what I could do is I'm going to take my polyplane and bring the poly count down. So bring it down to like 4-ish, right? And it looks like, let's take a look at this one right here. This is 16 polygons, right? And if I came to my plane, and it's 1, 2, 3, 4, 5, 6, 7, 8. So I probably want to bring it up one more subdivision level. So 1, 2, 3, 4, 5. Yeah, so this one should be good. And so then what I can do is I can, you know, just use this to cut into it, right? So let's go, let me go ahead and extrude this first, just so I have a volume to cut or subtract from the other object, right? So what I can do is I can grab this, and then go mesh Boolean difference, and I have that. And so I mean, like, this is okay. This isn't going to be a huge problem. The nice thing is I have like the right poly count. What I could do is I could easily just prepare the mesh with like a circular hole to make it easy to line up the topology. So let me go ahead and take a look at this. Oops. Right. So I might just grab these faces here. And what I'm going to do is let's go ahead and yeah, I'll scale this in for a second. And then I'll go ahead and use circularize to turn it into a sphere. Right? And then what I can do is let's unhide it. Let's grab these boundary edges and scale them out a little bit so they're not going to cut into this surface. So we'll pull it out like that. And then let's go ahead and extrude this forward. Right. So I'll take this, mesh Boolean difference. And you'll see I've created a pretty good topology. These edge loops all the way around are not, so before I do that, let's take my object. The problem is these edges are not evenly distributed across the boundary, right? Same thing, so what I might do is let's go ahead and Boolean that one. So in order to get those evenly distributed, I'm just going to make sure I click on circularize and just double check these guys. And then we'll just click on circularize. Okay, that one's good. And I'll do the same thing. Let's go back. And so we'll just take this mesh, mesh Booleans difference. And yeah, they're still not lining up, which makes me think that maybe these edges aren't actually, or maybe I have the wrong number, I'm not sure. But let's just try to start welding these guys together. So we'll go ahead and merge. All right. And just takes just a little bit of cleanup process. Take those guys, take those guys, take those guys. Okay. Okay. Oh, still got some that aren't welded. Come on, merge to the center. So these guys are being stubborn, which makes me think, I don't know, there might be something wrong with the mesh right there. So what I might do instead is use target weld and then just weld them together. See if I can get them. Or maybe I might need to do edit, delete by type, history, and maybe that will help me. Maybe it'll let me do it now. Merge. Still doesn't want to merge. What I can do is I just delete this face, and then we'll just delete that floating vertice. And then I'm just going to bridge that gap. There we go. And I'll just go normals, display, soften, harden. I got a weird shading. Oh, I know why I have that. I just need to assign my material to my whole object. There we go. All right, and now I have this flattened edge, and if I need to make it crisper, I could just add a insert an edge loop on the flat side to kind of just sharpen that edge. All right, and it has decent topology. So that's a bunch of different ways of doing Boolean to kind of like affect things. You know, we can get some really complex angles. I've just been doing kind of things straight onto the surface, but I could have put that cube at an angle. Cleaning up the topology would have been a little bit trickier, but it's definitely doable. So hopefully that helps, and that's the end of this one.